Okay, picture this. You get in a spaceship, fastest one ever built, you point it in one direction, and you just go. No stopping, no turning around. Where do you end up? Is there a wall out there somewhere? An edge? A giant game over sign floating in the void? Here's the wild part. That question messes with even the smartest physicists on the planet. Because the honest answer is, we don't actually know. And not because we haven't looked hard enough. It's because the universe itself might be playing by rules that make the edge a trick question. So today, we're going all the way out, as far as human knowledge can take us, to answer one of the biggest questions there is. What's actually at the edge of the universe? Let's get into it. First thing we gotta clear up, there's a huge difference between the edge of the universe and the edge of what we can see. We can only see so far because light takes time to travel, and the universe has only existed for about 13.8 billion years. So no matter how good our telescopes get, we physically cannot see light that hasn't had time to reach us yet. That limit is called the observable universe. From our perspective, it's a sphere centered on Earth, not because Earth is at the center of the universe, but because we're measuring the universe from here. Its radius is roughly 46 billion light years, bigger than 13.8 billion because space itself has been stretching this whole time while that light was traveling toward us. But here's the key thing to understand, and it's honestly kind of a mind bender. The observable universe isn't a wall. It's not a boundary. It's just the limit of our view. Kind of like standing in the middle of the ocean at night. You can only see so far before the horizon cuts you off. Doesn't mean the ocean stops there. Okay, so this is where it gets genuinely wild. Based on everything we've measured, the universe appears to be remarkably flat on the largest scales. That makes an infinite universe possible. But flatness alone doesn't prove that space goes on forever. If it is infinite, space doesn't stop anywhere. It just keeps going. More galaxies, more stars, more everything, in every direction, without end. That's genuinely hard for the human brain to process. We're wired to think everything has an edge, because literally everything we interact with in daily life does. But scientists want to be careful here. Flat and infinite aren't the same thing. A universe can be spatially flat and still turn out to have a finite shape. Our measurements are incredibly precise, but they're still measurements of the observable part of the universe. We can't rule out that on scales way bigger than what we can see, the geometry loops back on itself in some way we haven't detected yet. Here's option 2, and it's honestly the one that breaks people's brains the hardest. Some models suggest the universe could be finite but unbounded, meaning it has a limited amount of space, but still no edge you could ever run into. Sounds like a contradiction, right? Here's the classic way scientists explain it. Imagine an ant walking on the surface of a balloon. The ant can walk forever in any direction and never hit a wall or fall off an edge. But the surface itself is still finite. It's curved back on itself in a higher dimension. Now, quick clarification. The balloon isn't a literal model of our universe. It's just a way to visualize how something can be finite without having an edge. If our universe works the same way, just one dimension up, then, in some finite topologies, a path through space could eventually bring you back to where you started. No edge, no wall. Just a loop so massive it would take longer than the age of the universe to complete. Current data leans toward a flat universe, and that keeps the infinite possibility very much alive. But a finite, closed shape hasn't been fully ruled out either. Proving flatness alone doesn't settle whether the universe is finite or infinite. Scientists are still refining these measurements using tools like the cosmic microwave background. Okay, quick myth bust, because this trips up literally everyone. A lot of people picture the Big Bang like an explosion inside space, like a bomb going off in an empty room with the universe expanding into something. That's not what happened. Based on our current understanding, the Big Bang wasn't an explosion in space. It was the expansion of space itself. Our current models trace the history of space and time back to an extremely hot, dense early state. Not a single point exploding outward into some pre-existing empty room. So asking what's outside the universe might genuinely be like asking what's north of the North Pole. It's not that we don't know the answer, it's that the question might not even apply in the way we think it does. That's not scientists dodging the question, by the way. That's actually one of the most fascinating implications of modern cosmology. Now here's where things get spicy. Some cosmologists, working off theories like eternal inflation, which we've covered before on this channel, suggest that even if our universe has no edge in the traditional sense, it might exist as one bubble among countless others in a much larger multiverse. If that's true, the real edge isn't a wall you'd hit. It might be the boundary between our bubble universe and whatever lies beyond it. A boundary that could look completely different or follow completely different physics. To be clear, this remains a hypothesis, not a confirmed theory. There's currently no direct observational proof of a multiverse, but it's taken seriously because it emerges naturally from equations that already describe things we have confirmed, like inflation itself. So, yeah, even our best answer to what's outside might come with its own follow-up mystery. So, what's actually at the edge of the universe? Based on everything we know right now, there might not be one, just endless space, stretching further than any telescope will ever see, possibly forever. And if there is some kind of edge or boundary, it's not a wall you'd crash into. It's something way stranger, something that might not even follow the rules our brains are built to understand. Kind of insane to sit with, honestly. If you want to keep exploring questions like this, the ones that make you stare at the ceiling at 2 a.m., hit subscribe to Deep Space Files. Because out here, the biggest mysteries aren't the ones we've solved. They're the ones we're still chasing.